Welcome to the deep dive. Today we're tackling a question that's, well, it's been around forever, hasn't it? Are we alone?
It really has, this idea of life beyond Earth.
Yeah,
It goes way back.
exactly. And we've gathered some really fascinating historical viewpoints to explore this whole debate about, populated worlds.
Yeah, and the sources we're drawing on, they span quite a range.
They really do. From ancient Greece right up to, well, the beginnings of modern astrophysics, it gives us this fantastic historical backdrop for the current search.
The search for exoplanets and maybe signs of life out there.
So our mission today, really, is to understand how this whole debate evolved. What were the big arguments?
And how did the thinking shift over, centuries, even millennia? It's quite a story. From philosophy to actual science.
Okay, so let's dive right in, back to the beginning. Our sources show even the ancient Greeks and Romans were thinking about this.
Oh, absolutely. You had some really contrasting views back then.
Like Epicurus.
Yeah.
He was around the 4th century BCE, and he really went for this idea of infinite worlds.
He did. He famously said something like, hang on, let me get this right.
Yeah, I got it here. There are infinite worlds, both like and unlike this world of ours.
We must believe that in all worlds there are living creatures and plants and other things we see in this world.
I mean, that's pretty expansive thinking for, what, 300 BCE?
It really is. It's almost like an early form of the mediocrity principle, If it happened here, why not elsewhere? Loads of times.
But not everyone agreed.
Not at all. You had Plato, for instance, arguing completely the opposite. For him, it was just one unique creation.
A singular, only begotten, and created heaven, as you put it.
Right. So that fundamental tension, many worlds versus one unique world, was there right from the start.
And for a long time after that, it seems like this specific question, well, it wasn't exactly front and center for science.
Yeah, the sources mention that even after Copernicus, the big names,
Yeah.
Galileo, Descartes, Newton.
You saw the speculation, right?
Sure.
Kind of on the edge of proper science.
Yeah, pretty much. Maybe too philosophical, not really something you could test back then. The focus was much more on figuring out our own solar system's mechanics.
But then, between about 1500 and 1750, things started to shift.
They did. This idea of plurality, multiple worlds, started gaining real traction.
And it wasn't just one or two people. Our sources list a whole bunch of influential thinkers pushing this.
Yeah, people like Fontenelle, Huygens, even Newton was in the mix, alongside Bentley, Durham, Leibniz.
It seems like the idea was weaving its way into science, religion, and philosophy.
Which is what's so interesting. These different ways of thinking started to kind of converge on this point.
How so?
Well, some started seeing a universe full of worlds not just as possible, but almost as a logical outcome. If the universe was vast and governed by understandable laws, maybe planets were common.
And if God was infinitely creative,
Yeah.
maybe Earth wasn't the only place he'd put life.
Exactly. It fit with both the emerging scientific picture and certain theological ideas about God's power and generosity.
Okay, fast forward a bit. 18th, 19th centuries. Now the astronomers really seem to take the lead.
They absolutely do. You get figures like Thomas Wright, Immanuel Kant, Johann Lambert. They really embrace the idea.
Kant's vision sounds amazing. A densely denizen domain, like the universe is just packed with inhabited planets.
He had this idea of hierarchical cosmic structures, which naturally led to thinking about lots of planetary systems.
And then there's William Herschel, a giant in astronomy, but his beliefs about life elsewhere were intense.
Oh, Herschel is fascinating. He wasn't just speculating. He thought he saw evidence on the moon.
Yeah, things he called vegetation, turnpike roads, even circuses.
It's almost comical now, but it shows how much our perspective shapes what we see, right? He's looking through the best telescope of his day.
And interpreting lunar features as if they were, well, earthly.
Exactly. And he didn't stop at the moon. Mars, Saturn, Uranus, their moons. He thought they likely had inhabitants, too.
He even speculated about life on the sun.
Yep. Beings adapted to its peculiar circumstances, as he put it in 1795. It's a powerful example of how a strong belief can influence observation.
And it wasn't just him being eccentric. A lot of his contemporaries were on board.
That's right. People like Arago, Lalande, Schroeder, Johann Bode, they were all part of this conversation.
Bode apparently thought everything was inhabited. Every star, planet, moon.
Pretty much. He argued for rational beings just about everywhere. It was peak optimism, maybe, fueled by all the new discoveries.
And then Laplace comes along with his nebular hypothesis,
Right, around 1796, the idea that planets form naturally from the disk around a young star.
which would make planets common, wouldn't it?
That was the implication. If planet formation is standard, maybe life is too. It added scientific weight to the pluralist side.
People were even trying to calculate when life might start or end on other planets.
Yeah, the Comte de Buffon, around 1775, tried to work out timelines based on how long it might take planets to cool down. Ambitious stuff.
So astronomers were pushing this, but what about the religious and philosophical angles?
Still deeply involved. You had these figures called physico-theologians.
Right, they saw evidence of God in nature.
And for them, a universe full of life just showed God's incredible power and creativity. More worlds meant more glory to God, essentially.
So religious authorities often saw plurality as a good thing, reflecting divine generosity.
Often, yes, but not always. Thomas Paine, for instance, in his Age of Reason.
He rejected Christianity partly because of pluralism. How come?
Maybe he felt it undermined the unique importance of Earth and humanity in the Christian story. If there are countless worlds, what makes this one special?
Interesting. And the belief was getting pretty extreme in some quarters.
Oh, definitely. You
Yeah.
had James Mitchell in 1813 arguing for life on all planets and satellites.
And Thomas Dick in 1837.
Hmm?
His calculation is wild. Over 21 trillion inhabitants in the solar system.
Including Saturn's rings. It sounds absurd now, but it shows just how fervent the belief was.
Even cosmic events got folded into this.
Right. Samuel Vince, an astronomy professor, saw novae exploding stars as a...
But the destruction of that system, at the time appointed by the deity for the probation of its inhabitants.
Wow.
Yeah, fitting everything into a framework of life, purpose, divine plans.
But, okay, this peak enthusiasm in the early 19th century, it started to hit some snags, didn't it?
It did. The belief was still strong. I mean, people were proposing these huge engineering projects to signal the moon or Mars.
Like Gauss wanting to create a massive geometric figure in Siberia.
Uh-huh. And Littrow suggesting digging huge canals in the Sahara and filling them with burning kerosene.
All to say hello to the Martians or Lunarians.
Exactly.
Yeah.
And you still had astronomers like Wilhelm Olbers writing in 1802 about how convinced he was that the moon had rational beings and plants.
But then came Bessel.
Friedrich Bessel, yeah. His lecture in 1834 was a key moment. He used really careful observations, watching stars pass behind the moon's edge.
And he concluded.
That the moon couldn't have a significant atmosphere, the starlight just winked out instantly, no gradual dimming.
Which makes Earth-like life pretty much impossible up there. Right. That was a major blow to the idea of lunar inhabitants, which had been so popular. The observations started pushing back against the speculation.
And philosophical critiques came back too.
Yes, figures like Hegel raised objections, and then William Whewell's essay in 1853 was a big deal.
What was his argument?
He basically said, look, the arguments for lots of inhabited worlds are scientifically weak, there's no real evidence, and he added, it might even be religiously dangerous.
How so? Dangerous.
Maybe similar to Paine's point, potentially undermining humanity's special place, Whewell really kicked off a new round of more critical debate.
So the pendulum swings back a bit towards skepticism.
Or at least towards demanding better evidence. You had lots of people involved in this renewed discussion. Brewster, Powell, Ross, the popularizer Flammarion, Proctor, even Darwin was drawn in.
And right then, a new tool arrives. Spectroscopy.
Perfect timing, wasn't it? Suddenly you could analyze the light from stars and figure out what they were made of.
And the pioneers, Huggins, Angstrom, Draper, Lockyer, Secchi, they saw this as relevant to the life debate.
They absolutely did. They weren't just doing abstract physics. They saw themselves as contributing to this huge question about life beyond Earth.
That was a big breakthrough.
Well, Huggins and Miller in 1864, they looked at the spectra of dozens of stars.
And found the same chemical elements we have here on Earth, in the sun. Things like sodium, iron, hydrogen.
Exactly. It was the first concrete physical link. It showed stars weren't fundamentally different from our sun.
And their conclusion was
That these stars were probably surrounded by planets like our sun, a huge boost for the idea of exoplanets even back then.
And they went further, didn't they? Connecting the elements to life.
They did. They noted that the most common elements they found in stars, hydrogen, carbon, oxygen, nitrogen, were precisely the key elements for life as we know it.
So the quote is quite striking.
It really is. They suggested these stars could be upholding and energizing centers of systems of worlds adapted to the abode of living beings.
Wow. Directly linking stellar composition to the potential for habitable worlds. That must have shifted the debate again.
It definitely moved it towards something more grounded in physics and chemistry, less purely speculative.
Okay, so spectroscopy opens new doors. But people were still looking for evidence closer to home, right? In our solar system.
Oh, yes. The hope didn't die out easily. There were reports about changes in lunar craters like Linnae.
And people like Tesla and Marconi thought they might have picked up signals from Mars or Venus.
Yeah, those claims were made. And astronomers like Pickering were still reporting observations of what they thought was vegetation on the moon.
Even into the mid-20th century.
Remarkably, yes. As late as 1940, the British Astronomer Royal, Harold Spencer-Jones, felt Martian vegetation was almost certain.
But the biggest solar system controversy was Mars and its canals.
Ah, the canals. That was a huge debate, lasting roughly from 1877 into the early 1900s.
Started by Schiaparelli's observations of canali.
Which just means channels in Italian, but it got translated as canals, implying artificial construction.
And Percival Lowell really ran with that idea, didn't he? Building an observatory specifically to study Mars.
He did. Lowell, Flammarion too, became huge proponents of an advanced Martian civilization building these planet-wide irrigation networks.
But there was strong opposition.
Absolutely. Astronomers like Antoniadi, Campbell, and E. Walter Maunder were deeply skeptical. They argued the canals weren't real.
And the current thinking sides with them.
Yes, the favorite explanation now is the Maunder-Cerulli theory. Basically, it suggests the canals were an optical illusion.
The brain connecting faint, blurry dots and lines into patterns that weren't really there, especially when observing at the limits of resolution.
Exactly. It's a classic example of pattern recognition, maybe wishful thinking, influencing observation, a real lesson in scientific skepticism.
But a fascinating chapter. So the canals faded, but the question of life didn't entirely vanish for the solar system.
No, the possibility of primitive life, microbial perhaps on Mars or maybe Europa or Enceladus, that's still very much an active area of research today.
But the main focus now, for complex or intelligent life, has shifted outwards.
Largely, yes. Towards exoplanets, planets orbiting other stars. We've found thousands now.
And the big challenge is figuring out how to detect life on them, right?
Mhm.
From light years away.
It's incredibly difficult. Scientists are trying to identify the best spectral signatures, biosignatures, chemicals in an atmosphere that strongly suggest biological processes.
Like oxygen and methane existing together, perhaps.
That's one possibility. But it's complex. And as you mentioned earlier, we're mostly looking for carbon-based life as we know it.
Which might be limiting.
It might be. We have to
Right.
start somewhere, and Earth life is our only example, but it's definitely something researchers keep in mind. Could life be based on silicon? Who knows?
And then there's SETI, the search for extraterrestrial intelligence.
Right. That's less about biosignatures and more about looking for deliberate signals, radio waves, lasers from technologically advanced civilizations.
Which assumes they'd use technology we could recognize.
It does. SETI is often driven by this belief, or hope, that under Earth-like conditions, intelligent life might eventually arise.
This ties into some broader concepts, doesn't it? Like the anthropic principle.
And the mediocrity principle, the idea that Earth isn't special, just average.
And the fine-tuning hypothesis that the universe's constants seem oddly perfect for life.
Exactly. These are big philosophical ideas that hover around the scientific search. They're related but, unproven postulates for now.
And we have things like the Drake equation.
Trying to estimate the number of communicative civilizations in our galaxy by multiplying a bunch of probabilities.
Which gives answers ranging from one us to millions, depending on your assumption.
Precisely. It highlights how much we still don't know, which leads directly to
The Fermi paradox.
the big question. If the universe is so vast, and planets are common, and life might be common, where is everybody?
Why haven't we seen any clear evidence of other advanced civilizations? No probes, no signals, no galactic empires.
It's a profound puzzle. Lots of potential answers, but no definitive one. It really frames the whole search.
So, wrapping this up, it's been quite a journey we've traced today.
It really has. From philosophical guesses in ancient Greece to, high-tech searches for atmospheric chemistry on distant worlds.
And the core question remains, even if the methods have changed drastically, are we alone?
The quest continues. Definitive proof is still out there, somewhere maybe. But the search itself teaches us so much about the universe and about life itself.
And looking back at history, you see these huge swings in belief, don't you? Times when everyone knew the moon was inhabited, in times of deep skepticism.
It's a great reminder that science is a process, constantly refining its understanding based on new evidence, new tools, new ideas.
So, a final thought for you listening in. Thinking about this long history, the arguments back and forth, and where we are now with exoplanet discoveries, what do you find the most compelling argument? For or against life out there?
And what kind of discovery, if it came, do you think would truly shift our perspective on everything, on our place in the cosmos?
Something to ponder. It's a question that's fascinated us for millennia, and we'll definitely keep exploring it here on the Deep Dive.